Hello friends, welcome back to the CoDeSys tutorial. So in this particular video I'm going to give a glimpse of how we can configure Ethernet IP and adding a new instance assembly. So as we know in the CoDeSys we have a predefined EDS file, but if we want to change that EDS file and add a new instance assembly instead of utilizing the predefined one, it is pretty easy to do. Let's see. Okay, so let's start with adding the device. So we will add the Ethernet IP device first to see how the structure for the Ethernet IP adapter follows. So I have here two adapters, one is from Wago, one is from CoDeSys. So I'm adding one of the device. Then again Ethernet adapter is added. Then we can go to again local adapter and add Ethernet IP adapter. So click on add device, and then we need to add the Ethernet IP module. So that is the structure which we follow when we are working with Ethernet IP. So let's wait. Yeah, so I will add any of the Ethernet IP modules. So I have multiple, so I will add Ethernet IP module which is coming from the CoDeSys itself. Now if I double click on this, it will open a view where it will show consume data and produce data. So if you see, it has a number 64 and 65. Those are the basically instance assembly number. Okay, now what exactly does 64 65 means? So these are in hex code. So let me open the calculator. So as it is in hex, so let me show you how exactly it goes. So 64, if we put in the hex format, it is referring to 100, and same thing for 65, it will be the 101. So normally if you have seen how we configure is, even in the generic Ethernet IP adapter we have 100, 101 and 102. So this is very generic instance assembly number which in every Ethernet IP module we can utilize, but in CoDeSys it is by default present. Okay, now if we want to add another instance assembly, instead of utilizing 65, 64 and 65, I want to utilize 66, 67. How exactly we can do? So for that we use a tool given by ODVA, is Easy EDS. So in this one what we need to do is we need to get the CoDeSys adapter communication module, and we will open that in this particular tool. So when we open, it will give me all the details for that particular adapter communication module. Okay, so now what we need to do is we need to define another exclusive owner. So just see how exactly and the structure, how exactly it is maintained. So based on that we need to define those items at a certain place. So if you see in the assembly, we have different assembly, correct? So assembly 101, 101, 102, and proxy assembly 120 and 121. So which were coming in the when we were configuring the Ethernet IP module in the CoDeSys. So now if we go to each assembly details, it is filled with the data, and same thing. So this is for exclusive owner. So this is how exactly it is defined when we take that Ethernet pipe module into a scanner. Then that EDS will show exactly how it is configured. So, so we have here, yeah. So this is the exclusive owner where everything is defined. So in order to create, so we need to first create a different assembly. Okay, so how we can create, we cannot copy and paste here because that is not there in this particular tool. So we will go and add. So which one we need to add is, first we need to add assembly, because we need to create consume data, produce data. We can utilize the same config data assembly number, but we will create another name for consume, one for consume and one for produce. So we will give two, starting with 103, because 100, 101 and 102 are already there. So it is creating two, 103 and 104. So 103 for me is the consume data, and then we need to fill all other details, and 104 is for the produce data. Config, as I told, config we can utilize the same, so config data doesn't impact much. So because we mostly use consume and produce data, correct? So based on that, we can utilize 100, 101 or 103 and 104. Now when we go to consume, we need to define module reference. So which module exactly it will refer. So for that we need to create another proxy assembly. We can utilize the same one, but let's add the proxy assembly also, and same thing as number of instance to add, and starting with number. So already 120 and 121 are there, so 22 and 23, one is for consumed and one is for produced. Same way, how exactly it is defined for exclusive owner 1. So this is for consumed data. Now, so all these are now defined, correct? Now we need to have this module reference inside the assembly. So proxy assembly has to be referenced inside the assembly, so it will map. Now there are things, so we have lot of option to fill. Okay, so based on different configuration, we need to put a access type, how exactly it will access, and all those parameters. So we need to fill all those details. Now here in the module reference, once we have added, we can see the parameter. Now we can select and click on add. Same thing we will go and do for, so if you see, that is exactly how it is done for assembly 100 also. Same thing we need to do for produce data. Select the proxy assembly, produce data, and click on add. So let me first delete it and add it again. Okay, so now the reference member has been added. Now how exactly, there are few more parameters which we need to see and we need to fill, is how exactly they will be accessed, how exactly write is allowed or not. So all those details we need to do, so that we will configure later. So now we will add another exclusive owner. So this is, so how many items to add and what kind of, so it is normal entity or exclusive kind of thing. So we need to, so if you see in the connection one exclusive owner, we have all the details already filled. So either we can copy or same configuration we need to put exactly. So let's add this entry and give a name like exclusive owner 1, because exclusive owner is already there, so we will give exclusive owner 1. Then we need to define what kind of application type it will be, which direction it will be, and then the different triggers event and all those things. Now originator to target part we need to define, target to originator we need to define. So all those aspects we need to fill in this particular connection manager. Okay, so let me show you how exactly it is done for exclusive owner. So what are the things which is needed? So trigger and transport. So if we go here, we can not here, it will show. But normally when we add any adapter into the scanner and when we try to configure, it will show all those details, right? So we need to provide the path, how exactly the path is calculated. So all the things we need to configure here. So let's configure one by one. So like what are the transport class, what are the trigger modes, so cyclic, change of state. So these are needed. Just we can keep it aside. This one we have. So fixed size, O to T and T to O, real time transfer format we can leave, point to point, basically it's a support, multicast also. Now priority should be high or scheduled or urgent. I think we can either, so based on the need, so we can select all four even, or we can just select what is needed. So let's select all the priority. So it depends on how we want to configure our EDS file, basically what all the options we want to give in that particular. Now if you see in the O to D, then we need to provide the format. Okay, and same thing for the uh, target originator also. So let's configure these parameters. So we already have 103, so that we can add, and then for T2O we already have 104, so that one can be mapped. Okay, configuration I can keep as I told 102 itself, so I will not be creating that. Now we need to create encode path. So this is, even if you have seen, we need to provide that when we are adding the scanner, and then it asks for the path. So either manually or from the exclusive owner path. So same thing we need to do it here. So it has a different option to fill, what kind of class it will be, what will be the configuration path, what will the consuming path, what will the producing IO path. So let me first show you how exactly it is done in exclusive owner, so it will be easy. So normally we define the class as 4. Okay. Then the interface, so details. So as we want to do it for 66, 67, correct. So that way we can define it here. So let's define the class 4. So here we can define it will be 66 because we are using the same config option, correct. So our config option is 102 only, we are not using 105. So we can define here 66. Now IO path is 103. So 103 for the consuming IO path, which is 67, and producing IO path is 68 because it is 104. So the hex code for 104 is 68, and then we can encode. So now this is the path which is utilized, which will be utilized by the scanner to connect with this particular exclusive owner. So In this manner, we configure and generate the EDS file with all the details. Now everything is configured. Yeah. So now we can save this particular file. So yeah, this will be, there will be some warnings are present. So we can, it is a warning. So uh, either we can leave, or so we can just remove this one, because one warning was for this. So this is also done, and then whatever warning for produce data, so it was not selected here, so we need to select the module reference and add it. So now everything is correctly done. There is no difference found. Yeah. So these options anyhow we can fill according to the requirement what we have. Okay. So this is done. We can now save as. So I will overwrite that particular file. So let me take the backup, and yeah, we can save on that EDS file. So once it is saved, now what we need to do is the file is saved, so we have, now we can copy and paste that into the particular folder. To copy and paste, we need to go to program data, CoDeSys and devices. Inside devices, we need to find which particular folder. So 120, because if you have seen in the third drive adapter, its version shows as 120. So I'm going inside 120, and then here we have the communication module EDS, which we will be replacing with the new one which we have created. Okay. So but it is good to take the backup, so in any case if something happens we can restore it back, and then we can copy and paste it, the latest file which we have created. Close the CoDeSys, because once CoDeSys will uh, open, then only it will reload this particular file again. So once we reload the CoDeSys, now let me add the adapters. So adapters are added, modules is there. So I have, just to showcase, I am having two different module. So if you see here, it is showing both the options, correct, 64 and 67. Okay, consumed assembly. So that is what we had configured, and yes, so this is coming under 120, and the version number not under 4.4. So this is still the CoDeSys ADS communication module, but it was copied under Wago. Okay, so that is why I'm just trying to show we have two different communication adapter, but it is working, in which it is consumed and defined. So this is how we can configure extra instant assembly in the CoDeSys. So yeah, it is already configured. Now we need to also connect and see whether the data is getting exchanged or not. So in order to connect with any third-party device with or any scanner as this is adapter, we need to first configure the signals. So let's configure the signal in consume data parameter and produce data instance assembly. Okay, so just let's add the parameters. So I will create another one module and give a different instance assembly details. Okay, So now on this side it is all completed. Let me export this particular EDS file. So I will just change the name of the product. Instead of Ethernet IP adapter, I will put Ethernet IP adapter custom. And with that, I will export this EDS file and save it in a local disk. So once we have saved this particular file, now same file we can utilize in another PLC or any DCS where we need to communicate with. So for this one I'm using Rockwell. So in the Rockwell PLC we need to go to the tools and we need to register the EDS configuration file. So the EDS file which we have generated or we have saved, same we will utilize. So we need to register an EDS, register single file, browse that particular file where exactly it is, and open it. And click on next. If you want to select or change icon, you need to click on that particular item and then change the icon. So these are the things happening in the Rockwell side, and so it is successfully registered. So once this is registered, then yeah, we can configure it. So let's configure it by importing the EDS file. So yeah, we can say create, and it will take some time to get it created. Now we need to give here the names, we need to provide the IP address. So these are the basic things which we need to configure. And then we need to change also or add a new exclusive owner, because by default it will come with one and data type is real, so we will make it real. And then in the bottom we will see another exclusive owner one, and when we click it will get added. Now the default data type we need to change to real. Okay, so this is also done. Now all the configurations are done on both sides. So we can download the code, and we can check whether the data is getting communicated or not. So let's click OK here. It will give some message, but yeah, we can go ahead. So all the configurations are done. Let's scan the network and download the code into the CoDeSys. So one most important thing on the CoDeSys side, we need to actually map the variable also. So because if it is not mapped, then it is considered as not used, and if it is not used, then it means that it will not get scanned and the data will not get populated. So let's define the variables and then map it with the IO mapping of the Ethernet IP module. So now we will download the code on the Rockwell PLC on the Rockwell side, and already everything is configured. So we'll wait for the download to get completed, and then we can see that both the PLCs are communicating with each other on the Ethernet IP module. So let's wait to get it downloaded. So all the configurations are done. Now we can see in the controller tags all the tags are there. Now what we will do is we will exchange the data between both the PLC. So let me expand all the data controller tags, and then we can go to CoDeSys and change the value of the output from there, which will be the input for the Rockwell, and then we will change the output from the Rockwell to the CoDeSys. So let's go to the PLC program and change the values for both the analog output. So let's fill with some value, and then control F7. So it will write the value into those variables, and the same to be reflected in the Rockwell side. So let's go back to the Rockwell, and yes, we can see that it has been communicating. And now let's change the value of output from Rockwell, and we will see it in the input of CoDeSys. So if you see, all the exchanges are happening properly, which means that the EDS file which we have created is working fine. So yeah, that's all.
Thanks for watching. That's all for this video. See you in the next one.